Part B, we want to find the volume of the funnel. And so for the volume, we know that the volume is going to equal the integral over this whole interval from 0 to 10 of the area. Now, that area is going to be in terms of r for now, but I want this to eventually be in terms of h. So I guess I'll change that to an h. We want to figure this out. So the cross sections are circles, and we know a radius, so the area formula I start with is area in terms of r equals pi r squared. And that's great. But unfortunately, I'm going to be integrating with respect to height from h equals 0 to h equals 10. So I need to rewrite this, but we know that r is equal to that. So the area in terms of height is going to be pi times 1 over 20, 3 plus h squared, all squared. That's the radius squared. And I'll integrate that from 0 to 10. So equals the integral from 0 to 10 of pi times 1 over 20 times 3 plus h squared, all squared, dh. And let's do some work on this. So I can bring the pi out front. So integral from 0 to 10. I'll have the pi. And I can square this 1 over 20 and get 1 over 400, bring that out front. So I have a pi over 400 out front. And I'm left with 3 plus h squared, squared dh. And I can keep going. So I have this pi over 400 times the integral from 0 to 10. 3 plus h squared squared is 9 plus 6h squared plus h to the 4th dh. And now I'm just going to sort of skip over this part. So that's going to equal pi over 400 times this antiderivative, which is going to be 9h plus 2h cubed plus h to the 5th over 5, evaluated from 0 to 10. Putting in the 10, I will get 90 plus 2 times 1,000, which is 2,000, plus h to the 5th is going to be 100,000, divided by 5 is going to be 20,000. And that gives me 22,090 times pi over 400, so I get 22,090 pi over 400. And let's see, we can take out a 10 and get 2,209 pi all over 40. And just going through, 2 is a factor, doesn't go in there. 5 is a factor, doesn't go in there, and that covers all of the prime factors. So this is the volume measured in inches cubed.